Hey everyone, welcome to Unit 4, Day 5. And today we're still talking about transport, but we're switching gears from diffusion, which is passive transport, to active transport, which requires the use of energy. So we're going to go ahead and get started with active transport today. Let's begin. All right, so Unit 4, Day 5. Today's aim: how do materials, so we're talking here about nutrients and gases mostly, move across a semi-permeable membrane. So we have maybe a couple of things that we think of when we see semi-permeable, maybe phospholipid. Do you keep seeing me, guys, try to change color and it's not changing color? Oops. Phospholipid bilayer and this cell membrane. And this is with the use of ATP. And ATP, technical difficulties aside, ATP, I hope. Oh my goodness. Ladies and gentlemen, we got them. All right. ATP is energy. And I'm doing this word up here big because that's what we're talking about today. We are talking about transport that requires energy. So this is the contrast of diffusion. Diffusion easily happens naturally. It's the natural state of being of molecules. They are moving from a state of an area of high concentration to an area of lower concentration. That is just what they do. However, active transport is contrasted because active transport requires energy. Active transport goes against the concentration gradient. So it goes from an area of low concentration to high. All right, so let's go ahead and get started. Molecules A and B come in contact with the cell membrane of the same cell. Molecule A passes through the membrane readily, but molecule B does not. Which statement could describe molecules A and B? Molecule A goes easily through. So that could be molecule A could be maybe glucose, right, that we saw in the diffusion through membrane lab that passes easily through the membrane, but molecule B does not. So molecule B could be a starch. So we know that molecule B is not a simple sugar. Molecule B is not a simple sugar. Molecule B could be starch. Molecule A could be a simple sugar. Molecule A could not be protein because it passes easily through. And fats, we haven't really talked about their ability to pass through the cell membrane, but fat kind of repels fat, although fats could theoretically get into the cell, obviously, if they're broken down, and also maybe even through active transport, as we're about to discuss. But the correct answer is D. Yeah. Because obviously, as we know from the diffusion through a membrane lab, sugars easily pass through the cell membrane, whereas starch does not. Starch molecules are too large and must be broken down or digested before they can pass through the cell membrane. The second question, the diagram below represents movement of a large molecule across a membrane. So we can see here this carrier protein, this is one of the protein channels embedded in the cell membrane. So this is a large molecule, and this is how large molecules can get into the cell, like proteins. Proteins pass through proteins. And we can see here in the next image, this is ATP. In true to form, it's depicted with that little sunburst, right? And this is a phosphate group. And we can see here that the way the large molecule passes through is by ATP binding to the activation site and being expended, used up in this process. So we see ATP is being used. This is active transport. So it requires energy. Energy is active transport, right? Diffusion is passive. And you can think of that like you're being passive, you're sitting there, you're being active, you're running around, you're using ATP. And quite literally in your body, you are. But you're still using ATP when you're just sitting there because you're using ATP to survive. But this is active transport, and active transport requires energy. All right, let's go on. Part A, active transport reading. The movement of a substance against a concentration gradient is called active transport. So we see there against the concentration gradient. Active transport. So what does against the concentration gradient mean? It means from low to high. So going to be going from an area with just a few molecules to an area with a greater number of molecules. And this is the opposite of diffusion, which maybe should help you remember it. So when substances are moved from an area of lower concentration to an area of higher concentration, energy is used and work is done, right? It's work, it's hard to do. This kind of transport of materials across the membrane is one of the most important activities of cells. Other than using energy from your food to keep you warm, the most important use of energy in your body is to help pump substances across the membranes of your cells by active transport, a process that goes on all the time. Cells get the energy for active transport from ATP molecules. So cells get the energy from active transport from ATP molecules. So we make that ATP through cellular respiration. Our body uses that energy to keep us warm. So that's homeostasis, right? Of temperature. And then another extremely important thing that our body does is uses ATP to transport substances across the membranes of our cells against the concentration gradient, or molecules molecules that are too large to pass through the cell membrane otherwise, molecules that are too large to pass through the semipermeable membrane. But let's go ahead and continue. Your cells use the glucose in the food that you eat after it is digested. Oh, we're about to talk about cellular respiration. In a chemical reaction that required oxygen, the high energy chemical bonds in the glucose molecules are broken. Cell respiration. Because we talk about that all important ATP, baby. So the high energy chemical bonds, and see, we talk about those chemical bonds and the energy is in the bonds because that's very important. The energy, folks, it's in the bonds. If you've ever seen Arrested Development, the money is always in the banana stand. The energy is always in the chemical bonds. When glucose molecules are broken apart, carbon dioxide and water are formed. Again, this is the cellular respiration equation in words. The energy levels of the chemical bonds in the carbon dioxide and water are lower than the energy levels in the chemical bonds in the glucose because some of the energy is lost as heat. Thus, energy has been released. ATP is the substance in which cells store this released energy. So ATP is usable energy. Energy usable by the cell for active transport. And basically everything else that our cells need to use energy for, but in this case, we're talking about active transport. So let's name it. So active transport is the movement from an area of low concentration to an area of high concentration. Right, so the opposite of diffusion, low to high, with the use of energy or ATP. Where do our cells get the energy they need for active transport? Glucose, which is then converted into ATP via cellular respiration. And really, it's not just glucose, it's all of our food, anything that has those chemical bonds, organic molecules that have chemical bonds that store energy. What cellular process allows cells to produce ATP? Well, that's cellular respiration, of course. What organelle does this process occur in? Haha. Do we remember? I really, really hope we do, considering we just did a whole project about this topic. The mitochondria. Shout out to Mito, that Iris drew, that I now think of every time I draw the mitochondria. I'm gonna have to figure out how to copy your little drawing, so cute. Write out the equation for this process, label the reactants and the products. So we start with oxygen plus glucose yields ATP, CO2, and water. And the ATP is the most important part. And it requires oxygen, so it is an aerobic process. All right, so we take a look at the diagram down here. We can see passive transport contrasted with active transport. So this passive transport, this is, of course, diffusion. So this is what we've been talking about. But now today we started talking about active transport that requires energy. And now we're going to diagram a way to remember the difference between these processes. So you'll have to humor me, ladies and gentlemen, as I set this up. So all right, so we're going to start off with a little blast from the past for some of you, maybe, or maybe a blast to the present if you still have Disney Plus. And we're going to bring up our little friend, Baby Yoda. So, Baby Yoda, or the child, he's just very small, right? So, Baby Yoda is helpless. It's part of what makes Baby Yoda so beloved, and cute, is that you just can't help but support little Baby Yoda and want him to be okay. So, this is my very, 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 let's not do that, horrific depiction of little Baby Yoda. But imagine little Baby Yoda is at the top of a hill. And now, how did little Baby Yoda get up there? I'm going to guess he didn't use the Force, right? The Mandalorian probably carried him up the hill. So, to get up that hill from down here, low, all right, that required energy. To walk up the hill, that requires energy. But once Baby Yoda is at the top of this hill, you just, like accidentally knock him over when he's asleep. He's helpless, he's a baby. It's not going to take much energy to send little Baby Yoda tumbling down that hill. So, you got to protect little Baby Yoda there at the top. And little Baby Yoda here at the top of the hill. To bring in another Star Wars reference, he has the high ground, right? Baby Yoda is flying high up here, ladies and gentlemen. But when he falls back down that hill again, well, you've never been so low as Baby Yoda at the bottom of that hill. But you may have already started to pick up what I'm putting down here, folks. But in order to travel up this hill, there needs to be ATP used, right? In order to get up a hill, you need to use energy. But in order to go down the hill from high to low, no energy is needed. This is a passive process. if Baby Yoda's asleep, he'll accidentally fall down the hill. But in order to get Baby Yoda up the hill, Mandalorian probably had to like kidnap him from someone. You know, if you watch that show, it's all very high drama. But in this case, this is an active process, right? That's why it requires energy, because you're going from low to high, maybe high concentration of midichlorians. Right, we're going from low to high, like active transport from low concentration to high, that requires energy. Whereas passive transport does not require energy. It's more lazy. In order to get down the hill, it could happen by accident. This is diffusion. So diffusion diffusion is the natural consequence of molecules just sort of existing in space. They move from an area of high concentration to low concentration. You kind of can't stop them from doing it. However, active transport is like going up that hill. Active transport uses ATP. It goes from low to high. Low concentration to high concentration. Then diffusion goes from high concentration to low concentration. Okay, so if ever you need to remember what's going on, draw the hill, right? It's low, it's high. That part is easy to remember. And you can figure out going in the direction from low to high, that's active. From high to low, that's passive. Like you could easily accidentally roll down a hill, right? Rolling down a hill, you could do without using any energy. But to get up the hill, to get Baby Yoda up that hill, the Mandalorian had to work really hard. And I just like to make it Baby Yoda because Baby Yoda is so cute. There's no other reason why it's Baby Yoda. So active transport uses ATP, the all important usable energy from our cells. That equal sign is not really necessary. Active transport uses ATP and goes from low to high. So it's an active process. It uses energy and it goes from low concentration to high. Wow. Ladies or gentlemen who have ever done winged eyeliner, that's what just happened with that arrow. It got too big. But I encourage you guys to try to draw this diagram yourselves if you can. If you can't draw on it because you could draw it out on paper at least, even if you don't submit it to me, just to help yourself understand this process. Also, it's kind of fun. You could draw Baby Yoda. A little bit later, I think I'll have you guys submit this diagram the same way we had the photosynthesis posters, maybe next week. I don't know. It's awfully cute, right? But anyways, you know the drill. Drawing things helps you understand them. So that's why we're drawing this out. And this is really the whole unit kind of summarized, right? So we have active transport uses ATP and goes from low to high. Diffusion does not require energy. And it goes, no, where'd my pen go? From high to low. So again, low to high, like going up that hill, requires a lot of energy, but to get down the hill, no energy. And that's Baby Yoda. And that's all I have for you today, ladies and gentlemen. I hope you enjoyed watching me like perfect that diagram and like still not make it that cute. But c'est la vie. This was Unit 4, Day 5. Today we talked about active transport and how do materials move across a semi-permeable membrane with ATP. They usually move across a semi-permeable membrane with ATP by traveling through a protein channel. And we'll talk more about that process tomorrow. So don't forget to submit your exit ticket and then submit your guided notes. And I'll see you all tomorrow on Zoom. Bye, guys.